Chapter 8, Chemical Reactions, Section 8.1, Equations for Chemical Reactions. So now we're going to get into reactants, products, chemical reactions, signs of a chemical reaction, all that kind of stuff. So getting deeper and deeper here into chemistry. So what is a chemical reaction? A chemical reaction is when a substance is converted into one or more new substances. If it's not converted into a new substance, it's a physical change or a physical reaction. Right? There are 4 signs of a chemical reaction. Okay, these are sort of the given ones. Formation of a gas, okay, which you want to look for something bubbling. That means that the gas is forming. Now be careful, because boiling is not the formation of a gas. Okay? If something changes color, generally it's a chemical change, not always, but most of the time. If there is what's called a precipitate that's formed, which is a solid. Now this is usually technically a solid that comes from 2 aqueous solutions. Okay? And so the 4th sign of the chemical reaction is when heat is either given off or absorbed. So if heat is given off, which is produced, you're going to feel the reaction get hot. And if heat is absorbed, you're going to feel the reaction get cold. And we'll have some very specific sections on that, and then we'll cover it again in AP. So you'll be very familiar with that. Okay. So what is a chemical equation? Chemical equation shows the reactants and products. The reactants are on the left side of the yield symbol. The products are on the right side of the yield symbol. And so it's important from now on to start using the terms reactants and products instead of left side and right side. It's kind of like north, south, east, west. Use the actual terms, reactants and products. There are some symbols that are used in a chemical equation. So the first one is the addition. That just means that we're mixing these two things. We have a yield symbol. So that's what's called the yield symbol. If you're actually writing it out, it's usually just one arrow or half of an arrowhead, not both of them. Okay. If there's a triangle, the yield symbol means that we are heating that substance. And then finally, the 4 states of matter are 4 phases of matter that we're going to deal with: a solid, a liquid, a gas, and aqueous. All right? So it is important to be able to read and write a chemical equation. So the big thing about a chemical equation that we're going to look at in this chapter is that atoms are conserved in a chemical reaction. And this comes from Dalton's atomic theory, which you may recall we looked at that. So since they have to be conserved, we have to do what's called balancing a chemical equation. So a balanced equation has the same number of atoms for each element in the reactants and products. Same number in types, you should really say. Let's throw that in there. Same number in types. Types of atoms, all right? In a balanced chemical equation, it shows the law of conservation of mass, or the law of conservation of matter, which says that matter cannot be created nor destroyed during a chemical reaction. And that's a big law, right? That's an important one. Remember what a law does, by the way. A law just merely makes an observation, okay? All right, so let's take a look at this, and we'll talk about what the coefficients are. All right? So originally, let me show you this equation originally. It's just hydrogen plus oxygen yields water. Okay, no phase symbols. Here, let's throw some phase symbols in there. So let me do that again here. So it's hydrogen gas, so put a little G, plus oxygen gas, a little G, goes to form water, and let's say water is a liquid. Okay? Oh, they're showing it as a gas. We'll go ahead and show it as a gas too. Right. So notice here, yeah, we have 2 hydrogens on the reactant side, 2 hydrogens on the product side, 2 oxygens on the reactant side, but only 1 oxygen on the product side. So that is an unbalanced equation. That is not balanced. So what do? Well, we have to put coefficients in front of some of the reactants and products. Okay? What the coefficient does, it multiplies that chemical, that compound. Right? So for instance, the 2 in front of the hydrogen tells me that I have 2 of these. 1, 2. Right? Now, there's a 1 in front of the oxygen, but we don't show it because the chemical symbol itself represents the 1. But here we have a 2 in front of the water, so there's 1, 2. And so now if you look, we have 2, 4 hydrogens. 1, 2, 3, 4 hydrogens. And then we have 2 oxygens. 1, 2 oxygens. So we have the same number and types of atoms on each side. And so that's a balanced chemical equation. All right, so here's another way to sort of show it. All right, now in the next section we're going to actually balance these equations, so see you there.